The rack scale revolution, the illusion. Let's be honest. Most people look at Nvidia today, they see a $4 trillion titan and they think it's luck. They think Jensen Huang just happened to be in the right place at the right time with the right GPU when ChatGPT exploded. If that is your perspective, you are suffering from a surface level understanding of what is actually happening. In his latest talk with Lex Fridman, Jensen revealed a truth that will redefine tech for the next century. The era of chip-scale design is officially dead. For 60 years, our world revolved around the personal computer, one box, one chip, model for progress, simple. Build a faster chip, put it in a box, and that box gets better. It was linear, it was predictable. But we have hit a wall, a physical wall, a thermal wall, and a logical wall. Modern AI models like GPT-4 or Blackwell are so immense that no single chip, no matter how powerful, can process them alone. Jensen realized this decades ago. Nvidia didn't just build a better GPU, they redefined the concept of a computer today. The unit of computing is no longer the chip, it is no longer even the server. The unit of computing today is the rack, and the computer, the real computer, is the entire data center. This is the rack scale revolution. If you don't grasp this shift, you don't understand the future. Jensen explains that Blackwell isn't just a card, it's not something you just plug in. Blackwell is a system. Think about the engineering nightmare. A world where wires, cooling pipes, switches, and memory are all co-designed as a single biological unit. Nvidia is no longer building components. They are building the central nervous system of the AI revolution. And this nervous system has one primary enemy, latency. 2, the Blackwell system. Why has the rack become so crucial? Jensen emphasizes this. The biggest bottleneck today isn't the speed of calculation, it's the speed of communication. The problem isn't how fast one chip can think. The problem is how fast thousands of chips can talk to each other. Imagine having 2,000 geniuses in one room, but they only communicate by sending letters through the mail. The result? Total chaos. Traditional computing works like that. Nvidia answered this with NVLink, a high-speed nervous system that allows thousands of chips to share memory as if they were on the same silicon. This is rack-scale thinking. Nvidia is now designing the plumbing of the AI revolution. Jensen talks about liquid cooling, not as a luxury, but as a necessity. These racks consume massive power, yet they do so with extreme efficiency. He makes a profound point. Energy is the input, and intelligence is the output. If you can generate more tokens per watt, you win. Blackwell was designed to be the most efficient intelligence factory ever built. While competitors are busy trying to build a better chip, Nvidia already built the entire stack. They own the hardware, the software, the networking, the orchestration. This is why they have a moat that is miles wide. You cannot just buy a chip from one vendor and a cable from another and expect to compete. That is like bringing a knife to a planetary scale laser fight. 3, software 2.0. Now, let's talk about the controversial part. Software 2.0. For 50 years, we lived in the world of software 1.0. In that world, humans wrote every line of code. We wrote if-then statements. We defined the logic. The result? Humans were the bottleneck. Jensen says that era is over. In software 2.0, the data writes the code. The AI trains itself. It looks at massive data sets and discovers patterns that no human eye could ever see. This is why GPT-4 understands nuance, humor, and logic. Not because someone programmed those rules, but because it learned them through trillions of iterations. Jensen calls this generative computing. In the old world, computing was about retrieval. You clicked a button, computer retrieved a file. In the new world, the computer generates the answer on the fly. This requires a different architecture, a system that is always on and always learning. This is why CUDA is so valuable. It's not just a library, it is the language of the AI factory. Jensen predicts that soon, almost all software will be produced by AI. Humans will move from being coders to being orchestrators. We define the what, and the Blackwell racks figure out the how. This is a massive shift. If you are still trying to compete by doing manual tasks, you are already obsolete. You must learn to leverage the rack to multiply your intelligence, the tokens and electricity. Jensen Huang makes a comparison that changes how you look at the economy. Intelligence is the new electricity in the first industrial revolution. We turned coal and steam into physical power. In this new revolution, we turn data and energy into intelligence. The unit of this intelligence is the token. Every word, every pixel generated by AI is a token. Nvidia's goal: drive the cost of a token down towards zero. Why? Because when intelligence is cheap and plentiful, it becomes a utility, just like electricity. Imagine a world where every object has a digital brain. Your car, your house, your workflow, they all consume tokens to optimize themselves. Jensen believes we are building AI factories. A data center is no longer a place to store files. It is a factory that takes raw data and spits out refined intelligence. Nvidia doesn't just sell machines, they sell the ability to manufacture intelligence at scale. As a smart builder, your job is to figure out how to use these cheap tokens to create high-value products. The barriers to entry are disappearing. In the future, the only limit is your imagination and your ability to orchestrate agents. The Blackwell rack is the furnace of this new economy, and Jensen Huang is the one holding the shovel. 5. The Omniverse. Jensen believes that before an AI agent ever touches the physical world, it must live 1,000 lives inside a digital twin. This is the physical gap. Training a robot in the real world, slow, expensive, dangerous. Training in the Omniverse, a physics-accurate simulation, is fast and free. A robot can practice walking 1 billion miles in a single night inside a server rack. It learns from every mistake without breaking a physical part. This is why Nvidia is focused on graphics and simulation. Graphics aren't just for games. Graphics are the training ground for digital brains. Jensen describes a future where every factory, every city has a digital twin. We will simulate the weather, traffic before we ever make a decision in the real world. This is first principles engineering. It all runs on Blackwell. Co-design of hardware and software allows Nvidia to simulate physics at a resolution impossible. Just 5 years ago, we are building the matrix to train our digital employees. 6. Hierarchy is latency. How does Jensen manage Nvidia? He doesn't believe in traditional management. Nvidia is a very flat organization. Jensen has 50 direct reports. 50, no one-on-one meetings, no career coaching in the traditional sense. He believes in first principles transparency. If there is a problem, he emails everyone involved, VP to junior engineer, same context, same time. In a fast-moving world, hierarchy is latency. Hierarchy slows down information. And in the AI race, latency is death. Nvidia is always 30 days from bankruptcy. Not a slogan, a state of mind. It prevents complacency. It forces the company to take massive, bet the company risks. Biggest risk? Not technical failure. It's losing the will to invent. He encourages engineers to fail as long as they learn something from that failure. This culture, intellectual honesty, allowed them to pivot from gaming to AI when everyone thought they were crazy. Jensen isn't just a CEO. He is a lead architect. He spends time on the hardest problems, not on bureaucracy. Lesson for every leader. If you want to move at AI speed, kill the bureaucracy in your own life. The road to AG. When is AGI coming? Jensen has a pragmatic definition. If AGI is a system that can pass any human test, legal, medical, mathematical with high proficiency, then we are less than 5 years away. We see AI outperform humans in specific domains already. But Jensen is interested in agentic AI. A future where AI isn't a tool you talk to, but a teammate that does things for you. An AI that browses the web, uses a computer, talks to other AIs, completes tasks without supervision. This is the era we are entering. AI will not replace humans. It will amplify humans to an unimaginable degree. A single person will run a billion-dollar company. A scientist will solve diseases that plagued us for centuries. Intelligence cost is dropping. Our ability to solve problems increases. Jensen's vision is optimism. We are at the beginning of the most thrilling time. From the age of tools to the age of intelligence, the Blackwell rack is the engine, the 700-pound beast. To appreciate Blackwell, we talk about physics. Blackwell is a 700-pound beast, not consumer electronics, industrial infrastructure. Think about power and cooling. 208 billion transistors in one system. The heat would melt silicon. Blackwell is liquid-cooled, integrated into every layer, not just pipes. A co-designed thermal system, ensuring thousands of GPUs run at peak performance, moving from air to liquid, was the hardest pivot. It required rethinking how data centers are built. You can't just put Blackwell in an old air-cooled room. You design the center around the rack. This is rack-scale architecture. Energy and heat are the primary drivers of design. If you cannot cool the chip, you cannot scale intelligence. Nvidia solved this by becoming a thermal company as much as a silicon company. Vertical integration from transistor to pump makes Blackwell a masterpiece. Accelerated computing. Accelerated computing is the foundation of the bet. Traditional CPU models reach their limit. We can't just wait for faster CPUs. The free lunch era is over. We had to move to acceleration, taking specific heavy tasks and offloading them to specialized hardware, doing them 1,000 times faster. Jensen realized AI was the ultimate task. GPUs, parallel processing engines, the perfect habitat for neural networks. But acceleration is hard, requires rewriting the stack. You can't take an old program and expect it to run on a GPU. Nvidia spent $10 billion developing CUDA. $10 billion. They built the tools that allowed developers to speak. Parallel processing, a decades-long journey of extreme co-design. The chip, the library, the compiler, the framework focusing on specific workloads allowed the pivot when everyone was obsessed with general-purpose CPUs. They weren't building a faster computer. They were building a computer fundamentally different. 10. First principles. Jensen returns to the idea of first principles, not a buzzword, how he views every problem, designing NVLink or the organization. He asks, what is the fundamental truth? Networking, first principle, intelligence, depends on communication speed. Standard protocols like Ethernet lose too much time. So they built their own. They looked at physics, how electrons move through copper, photons through fiber. Look at the copper cables. In the Blackwell rack, people thought they needed fiber, expensive, power hungry. But Nvidia pushed the limits of copper, creating a passive low latency connector. It acts like silicon across the rack, saved massive energy and cost. This is the digital ASEAN mindset, finding the most efficient, technically sound path, even against conventional wisdom. Jensen doesn't follow trends. He follows physics. Synergy, the future. What is the human role? In the age of cheap intelligence, if Blackwell generates tokens for pennies and software 2.0 writes its own code, what is left? Orchestration. The human is the director of a massive orchestra of agents, defining the intent, deciding which problems are worth solving, providing the moral and ethical framework. Every human has a council of AI. One for research, one for design, one for finance. Agents communicate through rack-scale infrastructure, completing projects. That took 50 people in the past, not replacement. Liberation from drudgery of repetitive tasks. Jensen's vision is a call to action. Stop being intimidated, start being inspired. Blackwell is the most powerful tool created by human hands, up to us to decide what to build with it. The factory is open. The question is, what are you going to manufacture? 12, the blueprint. So, what is the takeaway? First, the chip is dead. The rack is the computer. Second, software 1.0 is ending. Software 2.0 is the standard. Third, intelligence is a utility. Tokens are electricity to thrive. Stop being a consumer. Start being an orchestrator. Don't just write an email. Build a factory of intelligence. Leverage Blackwell power via the cloud, the most important blueprint. You will see, Nvidia didn't become a giant by accident. They saw the rack-scale future long before anyone else. Now, you see it too. This is Digital ASEAN. Experimenting, analyzing, building the future. Thank you for watching. See you at the frontier. Signing out.